And here we have this complex fraction. It's 1 over x minus 1 plus 2 over x plus 2. And all of that divided by 2 over x plus 2 minus 1 over x minus 3. Right, remember, this is called the complex fraction because we have fractions within fractions, right? So this is the main fractional bar. We see two fractions on the numerator, two fractions on the denominator. So what's the approach here? Well, basically we want to get one fraction on the numerator and one fraction on the denominator, because then there's a step that we can do to take care of that. Okay, so the first thing we want to do then is just simplify the numerator, right? We'll do that separately. So we want to take the 1 over x minus 1 plus 2 over x plus 2, and then just add these together. Okay, so here the LCD, what's going to be the LCD here? It's x minus 1 times x plus 2. Okay, it's just each of the denominators, right? So then what we want to do is, let's rewrite each fraction with the LCD. Okay, there's two fractions here, right? So we'll rewrite each fraction with the LCD, and then we have to determine what the numerator gets multiplied by. So what do we mean by that? Well, the first fraction has a 1 on the numerator, x minus 1 denominator. This is the LCD, right? This is the equivalent form that we're building up to. So what do you notice has happened? Right? We have multiplied by x plus 2 on the denominator. So that means we should multiply the numerator by the same x plus 2. So when we look at the second fraction, this is the second fraction here. The denominator is x plus 2. This is the LCD. So what do you notice has happened here? We've multiplied by the x minus 1. Okay, so similarly, we want to multiply the numerator by that same x minus 1. Okay, so look what happened. We have the same denominator now, right? And that's the whole point. We can only add fractions when the denominators are the same. So once we get the same denominator, okay, we can combine these into one fraction that has the x minus 1, x plus 2 in the denominator, and then we'll just combine the numerators. Okay, so here you definitely want to be careful with your signs. Make sure you distribute properly. So we get the x plus 2 plus 2x minus 2. Okay, so we end up with 3x. Right, 3x over x minus 1 times x plus 2. And this is just what we get when we simplify the numerator, right? Okay, but the good thing about that is we've simplified it into one fraction. Okay, so now let's do the same with the denominator. Okay, so we have the 2 over x plus 2, and then 1 over x minus 3. So let's just write this down. What is the LCD here? Right. Similarly, the LCD is just going to be each of those guys, right? X plus 2 times x minus 3. So now what we want to do is we want to rewrite each fraction, okay, so that the LCD is in the denominator of each one. Okay, so we're going to put the x plus 2 times x minus 3 for each of the denominators. And now we want to determine what has happened, right? This is the first fraction. Okay, this is the LCD. What's the difference here? Okay, the difference is that we've multiplied this denominator by x minus 3. So similarly, we should do the same thing to the numerator, right? We should multiply the numerator by x minus 3. When we look at the second fraction, okay, this is the second fraction. The denominator is x minus 3. This is the LCD of the second fraction. Okay, what's the difference here? The difference is this x plus 2, right? So we want to do the same thing. We want to multiply the numerator by x plus 2. Okay, so let's take a look. This is the first fraction. This is the second fraction. Notice they have the same denominator now, and that's the key, right? We can only add fractions when the denominators are the same. So what do we end up with? We end up with x plus 2 times x minus 3. And then the numerators, we just want to combine together, right? So we get the 2x minus 6. And here's where you be careful, right? There's a minus sign here. So this x plus 2, okay, that minus sign should distribute, so you get minus x minus 2. And then for the grand total here, right, we get x minus 8 divided by x plus 2 times x minus 3. Now once again, this is just the denominator, right? We've taken the denominator here and we've subtracted them, and we've gotten this into one fraction. All right, so now what do we want to do? Okay, let's rewrite this whole thing so that we have the numerator as one fraction, right? The 3x over x minus 1x plus 2. And then the denominator is the x minus 8 over x plus 2x minus 3. Right, so let's think about that. Why do we combine it? Right? Why do we do the numerator and then why do we add those denominators separately? Okay, so remember this is one fraction, right? We have a fraction divided by a fraction, and there's a nice little property that you should know that will help us to simplify this even further, right? So when we rewrite this, we can rewrite it with this division symbol. Okay, so we are dividing these guys together, right? Okay, but as you should have learned, we actually never divide by fractions, right? What do we do instead? Okay, we multiply by the reciprocal of the second fraction here. Okay, so what does that mean? Really, this becomes 3x over the x minus 1, x plus 2, times now the reciprocal of the second fraction. Okay, so we're going to take the reciprocal of the second fraction. We'll put the x plus 2 times x minus 3 in the numerator, and then put the x minus 8 on the denominator. Okay. And this is good because it's a multiplication now, right? So multiplication is commutative. So now we should just be able to see if there's anything we cancel out between the numerator, and if there's anything we cancel out with the denominator. And here there is, right? We see that same x plus 2 factor. Okay. Is there anything else we can cancel out? At this point, there is not. Okay. So what's remaining? What's left in the numerator is the 3x times x minus 3. Now in the denominator, what's left is the x minus 1 times x minus 8. Okay. This is the final answer. This is the final answer because there's only one fraction here. So we've successfully simplified this complex fraction.